Hello, everybody. My name is Wesley Shamatula, and I'm a software engineer on the Enterprise Integration team. Today, I'm going to be talking to you about testing, linting, and automation in APIs. I'll be going over how we use our GitLab pipeline with the Person API to make sure our product works well, and is written well.
Wesley reads from slides.
I'll be starting out with an overview of the different tools we use and why we use them. Then I'll jump into a recent merge request and we'll see how they all work together in practice. I hope you can all find at least one new tool you aren't using yet and integrate it into your work. These tools are easy to add one at a time, and adding just one will make a big impact on your product. I'll be discussing Python-specific tools, but similar tools are available in most languages.
A pyramid-shaped diagram in 3 layers.
When I think of a maturity model for testing, I break it down into 3 categories. First, we make sure it works. This is the foundation of any successful product. We need to start off by making sure it meets the needs of our stakeholders. Second, we make sure it works well. This is the key next step. Our stakeholders need to have a good experience with our product. Finally, we make sure it is written well. This is the cherry on top. Both our stakeholders and developers need to understand what our product does to keep it healthy long term. Making sure our product works is the foundation of testing. Our product needs to meet the needs of our stakeholders in order to be successful. We also need it to meet their needs as soon as possible. The sooner our product is usable, the sooner our stakeholders can start getting a return on their investment. Additionally, we get the most valuable feedback on products once people start using those products. So as developers, we also want to get a product in use as soon as possible.
A blue and yellow plus-shaped logo.
The best way to ensure our product works is automated testing. Automated tests run our code and assert that it works correctly. There are 2 main categories of automated tests. The first is unit testing. These tests run a small isolated part of our product and make sure it returns the correct output. The second is integration testing. These tests run larger, more integrated parts of our product. These type of tests set our product into a predefined state, run some part of our code, and verify that the state has changed appropriately. The Person API is written in Python, so we use Python's own unit test library to run our tests.
A diagram of an imperative shell around a functional core.
Since automated testing is such an important part of making high-quality products, I want to spend some additional time discussing the differences between unit tests and integration tests. These differences start with your code, and thinking about your code in terms of an imperative shell and functional core can help you understand these differences. In this model, your core business logic is written in the functional core. These are pure functions that always return the same output for the same input and have no side effects. Code that needs to integrate with external systems is written in the imperative shell. The output of this code depends on the state of your product, and executing parts of this code can have side effects. Your pure functions in your functional core should be tested with unit tests. This code always returns the same output for the same input and doesn't have side effects, so we can simply call it with a variety of inputs and ensure each of those return the appropriate result. Your code in your imperative shell should be tested with integration tests. This code depends on the state of the product and can have side effects, so we need a more advanced approach. Using integration tests, we can set up the state of the product, run our code, and validate the response and new state after our code runs. Let's run through an example of how this works with the Person API. We get a request from a consumer to update a name. Our imperative shell receives the request and calls into our functional core to validate the name. If the name is valid, the imperative shell will save the name to the database and respond to the consumer. We write unit tests around name validation to make sure only appropriate names are valid. We then write integration tests around the whole request, making sure valid names are saved to the database and users get the appropriate response.
A drawing of a sleeping snake in a bed.
Automated testing of our product is so important that we must make sure we have tested our whole product. Code coverage tools let us monitor how much of our code is being tested. On the Person API, we monitor the statement coverage of our product. This works by running all of our tests while monitoring which statements of our code are executed. We then get the percentage of statements that were run by all our tests. We require that more than 90% of our statements be covered by tests. It is not necessary to have 100% coverage because not all code requires the same level of testing. Your core business logic in your functional core is something you must test. However, some high-level control flow code that calls into something that is already tested is not as important to test. We use the tool coverage.py for this in our product.
The pyramid-shaped diagram returns.
Once we've established our product works and meets the needs of our stakeholders, we need to make sure they have a great experience using it. There are a couple areas we focus on here. First, we make sure our product doesn't have any bugs. Anytime something goes wrong with the product, you're going to have upset stakeholders. Second, we make sure our product is fast. If the product runs too slow, we are going to have upset stakeholders because no one likes sitting around waiting for a product to load.
4 out of 5 star symbols appear under the plus-shaped logo.
Linting tools help us make sure we don't have bugs in our code. These tools are sometimes referred to as static analysis tools because they analyze your code without actually running it. There are a large variety of these tools with different focuses. On the Person API, we use Pilot, which has a wide range of features. It looks for errors in our code, like using a continue, break, or return statement in the wrong place. These are issues that would prevent our application from running. It looks for potential bugs, like an unused variable or an unreachable statement. These are likely mistakes and that indicate an issue in the code. It also looks for code smells, like duplicated code or overly complex code. This is code that would be hard to maintain or understand and could hide bugs. In addition to improving the quality of the code, these tools also improve the developer experience. When I'm writing code and tests, I get to focus on the features we need to implement. If I write some sloppy code while implementing the feature, Pilot will let me know and often provide suggestions on how to make it better. This lets me focus on the needs of our stakeholders and make sure we're making a product that works for them.
A logo of a flying locust in a green circle.
In order to make sure our product is fast, we need a measurement of how fast it is. Load testing tools let us measure how fast our product actually runs. We use Locust to load test our deployed API. This tool simulates many different users performing many different interactions at the same time. This puts our API under heavy load so we can measure performance at peak times. We have defined our target response time as 99% of requests complete in under 1 second. These load tests let us know if we aren't meeting our targets so we can prioritize performance improvements.
The pyramid-shaped diagram returns.
Now that we know our product works and works well, we want to make sure it is written well. From a stakeholder's perspective, we want our documentation to be written well. This is key to making sure stakeholders understand what our product does and makes it easier for us to bring in new stakeholders. From a developer perspective, we want our code to be written well. This makes it easier for us to work on our code and onboard new developers.
A logo shaped like a black and red helmet.
The main documentation our consumers interact with is the Open API specification for the Person API. In order to have a well-written specification, the API must work the way the specification says it works. We use the specification validator, DREAD, to make sure they are in agreement. This tool looks at your specification, calls all of the endpoints listed, and makes sure they return what the specification says they should return. As a developer, it's easy to make a small change in the code and forget to update the corresponding documentation. This tool prevents that from happening. If we change behavior and forget to update the OpenAPI specification, our pipeline will prevent us from deploying that change.
A logo of the word black in an oval.
From a developer's perspective, automatic formatting tools take a lot of the guesswork out of writing code well. To format our Python code, we use black. Black will format the code of everyone on your team to a very specific standard. Everything from line length, number of empty lines, string formatting, and more will be adjusted for us. This improves the developer experience since I don't need to worry about small formatting decisions while I write code. I can focus on making a feature that works and let Black handle the small decisions for me. It also makes code review a lot easier. Since everyone follows the same precise format, you reduce a lot of noise in code review. For example, you don't get meaningless changes where some white space has changed. You can focus your review on just the functional changes.
Text, let's see it in action.
Let's see all these tools in action in a recent merge request.
The screen opens.
This is a recent merge request on the Person API. When we submit a merge request, GitLab automatically runs our pipeline, executing all of these tools. First, it makes sure our code works by running our tests with code coverage. After tests successfully run, we can review a report on our code coverage here.
He scrolls down the list and clicks the link to index.html. A screen opens titled Coverage Report 96%.
We can see our total coverage is at 96%, meeting our overall goals. We can also see the coverage in each file. This points us to places where we can make further improvements.
He scrolls down the list of files and clicks on one.
Opening one of these files shows us the exact lines we haven't tested. This gives us direction to focus on in our future work.
Lines of code open, some of them highlighted. He returns to the first page.
Now that we know our code works, we can turn our attention to making sure it works well. The first tool run by our pipeline for this is our linter, Pylint.
He selects Pylint from the drop-down menu. The code opens.
We can see here that Pylint has rated our code at 9.95 out of 10, meeting our requirements. It has also given us some warnings and recommendations. For example, our function process JSON API request is too complex. This is something we can focus on improving in future work.
He returns to the first page.
The other tool we run to make sure our code works well is our load tester, Locust.
He selects Locust from the drop-down menu. Lines of data open in a new window.
This tool calls our API in a variety of ways and records the response time. We are interested in the 99th percentile column since our SLO is 99% of our requests complete in under 1 second. We can see here the average response time across all of these endpoints is 790 milliseconds, meeting our goal. This tool does show us that some of our endpoints, like the people endpoint with paging, is running slower than the rest. This gives us more direction for future work.
He returns to the first page.
Now that we know our code is working well, we can turn to making sure it is written well. The first tool here is our specification validator, Dread.
He selects Dread from the drop-down menu.
We can see here that Dread has called all of our different endpoints published by our API specification, and that all of these are passing. This has made sure that our specification and actual API are in agreement.
He scrolls down the list of data, then returns to the first page.
Finally, we make sure our code is written well and properly formatted with Black.
He selects Black from the drop-down menu.
We can see here that Black has checked all of our files and made sure they are all formatted according to its rules. This has made sure all of our code is consistently formatted.
A photo of a bowling alley lane with bumpers up.
Putting all of these tools together and running them automatically in a pipeline is like putting up bumpers in a bowling alley. With these guardrails in place, you'd have to do something pretty crazy to get a gutter ball and mess up your project. Getting a strike and knowing that new feature still takes skill and practice, but we've made it much easier for ourselves and reduced a lot of the risk. If you use a language other than Python, you should be able to find similar tools for your language online. For example, if you use Java, searching for Java linter will turn up a variety of options. I hope you can all find one new tool you haven't been using and integrate it into your product. It's easy to add these one at a time, and even adding just one will make a big difference. Thank you all for joining me today.